Hello, today we're going to talk about muscle twitch and contraction. So a muscle twitch is a single muscle fiber contraction that occurs when its stimulus threshold is reached. So the stimulus I'm talking about would be the action potential from the neuron. And so we're talking about the neuron action potential, and then we're talking about the muscle fiber, the muscle cell, and its contraction. And when you stimulate a muscle fiber one time, and it's enough as a stimulus, as a threshold stimulus, that means it generates an action potential, it actually causes something to happen, you're going to get a contraction, one contraction, and that's called a twitch. And so the stimulus, again, is from the nervous system, from the neuron. And what we're measuring here on this myogram is the muscle contraction, this muscle fiber contraction. So tension as the sarcomeres shorten, as the muscle fiber shortens over time. And so if you were to graph this out, you'll see once the nervous system has stimulated the muscle fiber, there is a small window that's called the latent period, where you don't actually get the sarcomere shortening. You don't get the muscle fiber shortening, or there's no contraction, because this is the time that it takes for that acetylcholine to cross the synapse, for it to bind to those receptors, for it to cause that depolarization on the sarcolemma, for that depolarization wave to spread down the muscle cell, to go into the T-tubules, to cause the calcium to be released, and for the calcium to then go out and bind the troponin, and then tropomyosin to move, and then actin and myosin can finally start to form those cross bridges, and you get contraction. So if everything I just said, you have no idea what I'm talking about, go back, because you need to understand those steps of muscle contraction. So all of those steps occurred in the latent period. Now this is where actin and myosin are actually coming together, and you've got those cross bridges, and you've got the sarcomere, the little actin and myosin doing this, and the sarcomere shortening, and you're producing tension. This is the contraction period. Once it reaches its maximum contraction, it's going to start to relax, and so relaxation is a little bit slower. This is where the calcium's been taken back up into the sarcoplasmic reticulum, and the actin and myosin are releasing, troponin and tropomyosin are changing shape, and the muscle begins to relax. So one stimulus on one muscle fiber causes what's called a twitch. Now, twitches are not standard across all muscles. We have muscles that twitch faster than others. And so we have, if you were to look at muscles, so for example, these extraocular muscles, so ocular means eye, so the muscles around the eye, they're really fast. And you can imagine if you were to watch someone read, you'll see their eyes tracking back and forth really, really quickly. So these muscles contract and relax really fast, so they have a fast twitch. Gastrocnemius muscle, which if you haven't learned that yet, that's the muscle in your calf. It's a little bit slower than an extraocular muscle. If you can just imagine that your gastrocnemius doesn't move as fast as your eye muscles. It's got a slower twitch duration. And then the soleus is a muscle that's deep to the gastrocnemius. It kind of aids the gastrocnemius. So if you've learned anything about synergistic muscles that work together, the soleus helps the gastrocnemius do its job, but it contracts and relaxes a little bit slower. So all muscles are not the same. And you'll see a lot of times that muscles that are more postural, are more supportive, more stabilizing, that don't need to move and contract quickly, they have these slower twitch durations. Whereas muscles that do fine movement, like your eyes and your fingers, will have a faster twitch. So just to kind of review, if you have a stimulus, again, this is the stimulus from the nervous system, you're going to have one stimulus equals one contraction. Okay, so that's a single stimulus equals a single muscle twitch. And that's pretty basic, right? Now what if you gave multiple stimuli? If you stimulated it over and over and over again? So if you do a repeated stimulation, the muscle contraction force will actually go up. So let me show you what I'm talking about. So remember, each one of these red arrows is a stimulus or an action potential from the nervous system. So you're going to zap the muscle and you're going to see a contraction. Well, what if before it relaxes, you send another signal, another stimulus? Well, because you've already, the muscle's already contracted, but it's starting to relax, you're starting at a little higher set point, it can contract a little bit harder if you stimulate it again. So you're going to see a more forceful contraction. If you hit it again before it relaxes, an even more forceful contraction. Until finally you'll hit a level of stimulus where you've got your most forceful contraction, you're completely contracted. So if you repeatedly stimulate a muscle before a muscle fiber can relax, you'll get a more forceful contraction until finally you get the maximal contraction. And this is called incomplete tetanus. So if you stimulate it at a low frequency, but before the muscle can contract or relax, you will get a more forceful contraction. So what would happen if you used a high frequency of stimulation? If you stimulated the muscle cell repeatedly, if you did a stimulus from the nervous system, an action potential, over and over and over again really fast before the muscle had a chance to relax. So instead of getting this type of response like we did in the previous slide, we got an initial rise in contraction or tension and then a sustained contraction. So if you hit the muscle over and over and over again before it can relax, you will get this sustained contraction, and this is called tetanus, or fused or complete tetanus. And so the higher frequency you stimulate a muscle, you'll get this sustained contraction. And this is really how muscles work. If you want to actually pick something up, you need a contraction to be strong and to be sustained. So if I wanted to pick up my phone and hold it for a while, then I need to be in tetanus so that that muscle is staying contracted and holding up my phone. So that's really the way a muscle would work. You don't really see that incomplete tetanus where it kind of does like that. You really see a muscle work more like this, okay? Now, I want to say one more thing. I don't want you to confuse that tetanus that we just talked about with the tetanus that's a disease. There's a disease called tetanus, which is caused by the bacteria Clostridium tetani, and we may have heard that called lockjaw. This is a bacteria that's found in the soil, and so if you step on a rusty nail, it gets into your body, and this bacteria will basically affect some things going on at the neuromuscular junction. And it will cause your body to seize up. You'll get these sustained contractions. This is actually an old painting of someone that's suffering from tetanus. So again, don't get the tetanus that your muscles do all the time when they pick up something and hold a sustained contraction. That's called tetanus. That's not the reason you get the tetanus shot. You get the tetanus shot so that you won't be affected by Clostridium. Now, the reason it got its name tetanus is because of the tetany is the sustained contraction of a muscle. And so the result of getting this bacteria is to have this arched body with every muscle contracted called lockjaw. So again, just don't get those confused. I've had some people ask me, is that why you get a tetanus shot? No, it has nothing to do with what your muscles do. It has something to do with the toxin released by the bacteria Clostridium tetani. So that's going to end this talk, and I will see you in the next video. Thank you for your attention.